There's obviously a huge energy agenda, but that's not my expertise. And then there's a really interesting piece of emissions, which you probably all know about, but most of the world doesn't pay much attention to, which is that even today, a significant fraction of annual emissions comes from the destruction of modern ecosystems, particularly tropical forests. Maybe, I would guess, no longer 20%, but in absolute terms, still a significant number, maybe pushing 15%. And so one of the things one can do is actually protect a lot of biological diversity by avoiding the destruction of those ecosystems. And this is the basic equation that we have to play with, because I think we've arrived at the point where we actually need to consciously think about managing the planet and the climate system. So in any given year, about 5 times the amount of tropical deforestation emissions is emitted by burning fossil fuels, and about half goes in the atmosphere, and the rest is divided between the oceans and the land. So the idea is, how can you start playing with this equation? So maybe you could even reverse one of those arrows. And it becomes really important because of the length of time greenhouse gases stay in the atmosphere. It's 100 to 1,000 years. The longer they're there, the more they are actually contributing to the warming of the Earth. So then we come to sort of the wilder idea here, the wild contribution to climate change, which is looking at ways to actually pull CO2 back out of the atmosphere long before it has generated some of the climate change and the consequences that might otherwise be the case. And it turns out that over about 3 centuries, there's been a lot of CO2 going into the atmosphere from ecosystem destruction. And the power of biology in all of this is actually considerable. So twice in the history of life on Earth, there have been screamingly high levels of CO2 brought down to pre-industrial levels. The first time it came down was with the arrival of plants on land. And it wasn't just plants, it was also soil formation and all the biodiversity in the soil involved in generating soil. The second time was with the arrival of modern flowering plants doing the same thing, but more efficiently. So the power of biology in all of this is considerable. It's fact. It's historical, geological fact. The issue is that we don't have tens of millions of years for that to happen in any natural kind of time span. So the really interesting thing is maybe something like 40% of the excess CO2 in the atmosphere actually comes from 3 centuries of destruction and degradation of modern ecosystems. So it should be possible to actually do planetary scale ecosystem restoration and bring a significant portion of that CO2 back into living systems. So this is my original little sketchy diagram suggesting this about 5 years ago. And the REDD up there is just about reducing the emissions from deforestation and degradation. That's a technical UN term. But the bigger potential impact is ecosystem restoration. So I think there's actually no question about it. Checked it around with IPCC and the rest. There's at least 50 parts per million that could come out of the atmosphere by planetary scale ecosystem restoration. And that's the difference between 350, which is sort of safe, and the 400, which has recently been measured in various places in the Arctic. Global average is 395, but the first readings of 400 have showed up in the Arctic. In the last time, by the way, this planet had 400 parts per million was 800,000 years ago. Anyway, the difference of 50 parts per million is something that could actually be done by ecosystem restoration over a 50-year period. And so it would be 500 million tons a year through reforestation and managing forests more effectively from this perspective. Another 500 million tons a year by restoring grasslands and degraded grazing lands with the great benefit of better grazing. And a third 500 million tons a year through managing agroecosystems in ways that will encourage them to build up carbon in the soil rather than leak it. And the more carbon there is in soil, the more fertile the soil is. So there are ancillary benefits from this kind of approach. So, and we can do all of that and still worry about feeding the additional 2 billion people this planet is going to have to feed, and who knows, maybe a bit more. But it's possible to do all of that without encroaching on the agricultural potential of the planet. So I think in the end, if we start thinking about managing the planet as a system, we can literally deal with a really important part of this climate change challenge by re-greening the emerald planet and using the living planet to make it more habitable. Thank you very much. So anyway, the good news here is we don't all have to go to the nearest bar and never reappear again. There are things you can do.